Hey everybody, it's Mr. Kane here again, and this video is all about energy, which is kind of weird stuff to deal with. It's not like this beaker of water. You know, the beaker of water, we know exactly how much we've got, what kind of stuff we've got in there, and being water, if we really wanted to, we could take the atoms that make water apart, the hydrogen and oxygen, we could separate them and get rid of it, or we could even make it. We could put hydrogen and oxygen together and make water. Whereas with energy, we can't make it, we can't even destroy it, and sometimes it's actually hard to see how much we actually have, but we're quite good at doing stuff with it. So let's go for a little bit of a journey and learn a bit more about energy. Energy, well, it allows us to do things, do stuff. Science says energy is the ability to do work. That's basically just anything really that we can do. Moving things, pushing things, moving ourselves, making lights go, the radio work, the TV play. Energy lets us do stuff. So here's the question though. What do we need to move? Okay, so you should know that it's energy. So where do we get that from? That a hint? Food. So what exactly is energy in food? Well, hopefully by the end of this video you'll be able to tell me exactly what kinds of energy are in the food. And in fact, nothing at all would happen without energy. Nothing. We'll be here in the dark. Well, we wouldn't even be here. We need energy just to be. So, types. This is where it gets a bit easier, because there's only two. Two major types of energy. What are they? Active energy, or we call that kinetic energy, and stored or potential energy. Simple. Active or stored. Kinetic or potential. So let's go and explore those. So active, it's moving energy. It's active. So anything that's involving energy that's moving, easy, active. Here's my beaker of water. I'm moving it about. It has kinetic energy. The water's sloshing about in there. It's got kinetic energy. Easy. Stored and potential energy, okay, it's waiting to happen. It's stored there. That's a little bit trickier to see. Rubber band. I'm moving it about. Kinetic energy. It's just this floppy rubber band. Not much going on. However, if I put energy into it, I hold it, I pull it back, stretch it, now it's got stored potential energy in it. Okay? Oop, gone. We'll find that later. So, what forms do these energies come in? So there's two types, active and kinetic, but they come in many different forms. So let's look at some of the active forms first. Kinetic energy. There's the car moving. Electrical energy. Plug the cords in, electrical current will flow through the wires. Sound energy. You're hearing my voice through sound waves travelling to you. That's sound energy. Heat and light. Okay, light bulb goes on, you can see the light waves are travelling to you. Heat from the heater, from the sun, that's heat energy travelling to you. These are all active kinetic energies. Active because the car is moving, it's active. Electrons move to make electricity. The current flows down the wire. Sound waves are moving from the source, that's me at the moment, from the speaker to you. It's active energy. And heat and light also move from their various sources to you. So, stored energy. Where are some of the basic types of that? Gravitational potential energy. Okay, what's that look like? What about chemical energy? Okay. There's some there. We'll learn about more of it in a moment. Strain energy. Okay, I probably saw that at the rubber band. Nuclear energy. Okay. Sometimes we'll call strain energy elastic potential energy. Okay, but then these are all stored energies, and we'll how to explain those. Stored because high objects have got potential to do stuff. You know, they can fall down. You know, you get the roller coaster to the top of the track, and it will roll on down through wherever the track takes it. It's got potential to do stuff once it's at height. Okay, think of that brick way up there, sitting on the shelf. It's got potential to fall off, and if it did, it'd hurt. That's the energy in it. Chemicals, they've got energy in the bonds holding them together. And that's where we get the energy from the food that we eat. The chemicals stored in it. Probably the easiest example to think of is when you fill up your car at the petrol station, the energy in the petrol powers the car. We explode the petrol. The bonds of energy in the atoms in the petrol release the energy to let the car move. Stretched or squashed things have energy stored in them. You saw that at the rubber band. I stretch it, it's got energy stored into it until I let it go. Squashed objects. You inflate a ball and hit it with a tennis racket or kick it with a foot, and you're squashing it, and that elastic squash energy gets released and the ball fires away. And atoms have actually got energy holding them together, and that's stored in them, and we can release that sometimes in uncontrolled fashion, and we have what's called an atomic bomb, or in a controlled way in nuclear energy reactors, which lead to other issues. So, types and forms, we've been through most of them now. We can easily transfer, move energy from one thing to another. That's easy. I hit the bat against the ball, the energy in my swinging of the bat gets transferred to the ball, and the ball then moves, as long as I can hit it. We can also change energy from one type to another. At the moment, I'm taking chemical potential energy from inside of me, converting it to sound and motion as I'm talking to you. We take current electricity and turn it into light, into sound, into pictures on the TV. We can do this easily. We just can't make energy and we can't destroy it. We just turn it from one thing to another. We can follow it in an energy chain. Okay, for example, the radio sound. Where does that come from? Okay, electricity is driving the radio and making the sound. Where'd that energy come from to be electricity? Kinetic energy. It was flowing down the wires to become to the radio. So where did that come from? It came from kinetic energy in the generator at the dam making the electricity to start with. So where did that come from? Gravitational potential energy of the water sitting up behind the dam. Then it flowed down into the kinetic energy of the turbine, which flowed along the wires to make electricity to power the radio. We can keep going on and on and on. In fact, if we were to keep following these changes, where would we end up? Can you think of an energy chain that doesn't end up at that place? There's some challenges for you. So try those out and check them in with your teacher and see if they know the answers too. So that's energy. I hope that was interesting and helpful.